the lessons are shorter, and it affords us even extra time to focus in on the homework. So as we go through this homework, I'm going to give you the correct answers now. If you have very quick questions, I can answer them. Otherwise, you can come into extra help, or if we finish the lesson early, you can ask them at the end of the period. But I do want you to know what right and wrong is. Miss Ma, if you would please kill those lights. Thank you. Okay. Now, here are the correct answers. Let's scroll through all the correct answers first, and then if you have any quick being the key word, questions about these, I'll be happy to answer. If it's a long, drawn-out thing, the work is going to have to do, okay? When it comes to looking at these functions and seeing which are modeled by a data set, you can just plug the coordinates in and see if they check. That's a great way to do it, okay? In the case of a parabola, we can also do vertical and horizontal shift. Okay. Also, an exponential, we could do that too as well. All right. Then it says solve each for the variable. These are two excellent questions. You have to be, at this point in time, you need to look at these two questions up here and say to yourself, I got that. I know what I'm doing. I know I have my plan. I know what to do. Granted, we all occasionally make sloppy mistakes, but barring a sloppy mistake, your technique, your strategy should be spot on by now. If it is not, you have got to get to extra help and work it to the point where it is. Yes?
Negative 20 times 3 isn't positive 60.
Oh, okay, sorry. It should be negative 60 then. Yo muy malo. Okay, next one. Completing the square. We haven't done many like this where there's a 2x squared in front. Divide out the 2. Get rid of it. Otherwise, you're not going to be able to do a perfect square. So I divide out the 2. That leaves me with x squared plus 5x is 2. And that's still kind of weird because half of 5 is 2.5, but you got to go with it. And it's not very difficult because you have a calculator and you know that 2.5 squared is 6.25. Okay? All right. Equation of a line here. Parallel lines have the same slope. So you got to find the y-intercept on the other line, slap it in. Okay, some nice little function evaluation questions here to practice different skills. One really cool one to practice a particular skill on is a question like letter B, where you know to take the square root of 9, make it 3, and then 4 times 3 is 12. And then on C, you have to simplify radical 20 into radical 4 times radical 5. And the square root of 4 is 2, so 4 times 2 is 8 radical 5. Those are things that I think is a work in progress. I don't think we're great at those. And we will continue to see one a day, one every other day, from now right through the Regents exam. And, you know, by then it should be down pat. Okay? Okay, next one. Function f. There's no limitations for the domain. You just plug it in. Okay? The range, it's got to be greater than or equal to negative 3. And you could just look on your calculator and you would see that. Or greater than negative 3, not or equal to. Domain and range for g. The thing about g is that you cannot get a negative under this radical. You can have a 0, but you can't have a negative. So it's going to be x greater than or equal to negative 1. And the range is, the square root of anything is 0 or higher. It's always positive. So y greater than or equal to 0. Which will have a vertex or a corner when graphed? Choice D. Okay. Next one, nice little question here. Let's see if you were able to figure out the contexts and the correct equation for each of those. Take a look. This is kind of the work we were doing yesterday and the day before. Take a look at your answers. Do you have any questions? Are we all good? Okay. It's very difficult for me to know if you're comfortable with that or not. I hope that you are. All right, next one. What I notice here is that this has to be quadratic because of the way the differences are changing. First a difference of 10, then 6, then 2, and so on and so forth. So I fill it in by working around that, and the minimum would be the 0.4, -8. Okay, so those are your homework answers. Hopefully you got a lot of verification in terms of what you think you know, and some confidence in terms of what it is that you are doing. Okay, what's today's sheet number? 33?
34.
34. Okay, Gregory plans to purchase a video game player. He has $500 in his savings account. He plans to save $20 per week from his allowance until he has enough to buy the player. He needs to figure out how long it'll take. What type of function? What type of function is this? Is it linear, quadratic, exponential, none of the above? What do we got? Linear, because it's going up by 20 a week. It's a constant difference. Good. Example 2, one of the highlights in a car show event is a car driving up a ramp and flying over approximately 5 cars placed end to end. The ramp is 8 feet high at its highest point, and there's an upward speed of 88 feet per second before it leaves the top of the ramp. What would that be? What kind of function? Quadratic. Very good. Margot got $1,000 from her grandmother to start a college fund. She's opening a new savings account and finds out that the bank offers 2% annual interest compounded monthly. What kind of function? Exponential. Very good. Okay. Now we go to, we did the homework answers already. City workers recorded the number of squirrels in a park over time. At first count, there were 15 pairs of male and female squirrels, 30 total. After 6 months, they recorded a total of 60 squirrels. After a year, there were 120. What type of function of squirrels recorded over time are we dealing with here? What do we got? Who said exponential? Exponential is correct. Who hesitated? Or how is it your brother does it? That's it. Not good. Listen, exponential, what tells you that something is exponential? A common what? That's one way to look at it, or ratio, okay? Whether you want to look at it as a multiple or as a ratio. Listen, a common difference? I believe, too. I believe I have to smack it. Yep. Now I should be reconnected. Good. Okay. What type of function can model it? Well, look, the first thing is there's 30 total, squirrels total. Then there's 60. Then there's what? 120. Now, is that a common difference? No. Does that look like it's going to be quadratic? No. Highly unlikely. On the other hand, is there a common ratio? Yes. What comes next?
240.
240, right? What am I multiplying by to go from place to place to place to place? By 2. So what's next?
480.
480, good. And this is a classic exponential function. Okay? Now, write a function that represents the population of squirrels recorded over X number of years. Explain how you determined your function. Now, the common ratio is 2, so that means it's doubling. So I'm going to go 2 to the x minus 1 and 30 times it. Now, remember, this is a lot like when we came out with the formulas for sequencing. This is always the initial amount, 30. And it's always times 2 to the x minus 1. And we always put x minus 1 as the exponent. And the way you can check that, if x is 1, doesn't the answer have to be 30, right? Because this is the first population time, the second, the third. Agree with that?
Yeah.
Okay. So if I plug in a 1, what's 1 minus 1? What's anything to the 0 power? 1. And then 1 times 30 is? 30. So this is always the initial value. This is always the common ratio. Again, we've been over this, so you should be comfortable with it. And that is always going to be x minus 1, because I got to get to 0 to make the first one. So that's why it's always x minus 1. Okay? Preguntas? Okay. Here is my rectangular picture frame. Here is my picture. Then there's the frame going around it with a uniform width of x. This was 8 by 10, so it's 8 by 10 there. This, if you remember, this is an x and an 8, so this is 2x plus 8. What's the length here?
10.
It's not 10.
What?
2x plus 10,
Oh, well,
right? Because of the x here and the x here.
there we go.
Now, this is about area, so what kind of function is this going to be? Quadratic, right? Because I'm going to do 2x plus 10 times 2x plus 8 as part of solving the problem, and the very first term is going to be 4x squared. And as soon as you see that x squared there, what do you know we're dealing with? Quadratic, okay? All right, write an equation representing the area of the picture and the frame. Okay, so let's keep going. 4x squared plus 16x plus 20x plus 80. So I get 4x squared plus 36x plus 80 equals y or f of x or whatever you want to say. Okay? It equals y because this function tells you what the area is. And based on the width of the frame, the area changes, and x represents the width of the frame. So if the width of the frame is 5, it's going to be a different area than if it's 10, than if it's 1. Okay? All right, any questions? Yes?
So we have to simplify that down.
You do not need to simplify it down. It says write a function. However, if you factored out the 4, it would also be correct as long as you made no mistakes along the way. All right, do we have any questions here? Okay, you may work on your homework together. Please pay, it's just such an important time of year for homework. We're actually doing so much Regents Review each and every single day through the homework. And if there's anything you find that you can't do, it is a great time to discuss it.